Section 2.2, linear functions. So in these notes, we're going to identify linear functions. We'll write them in standard form, and then find the x and y intercepts using standard form. So a linear function, that's what we'll put here. A linear function is a function of degree 1, which graphs a straight line. By degree 1, we mean the variable on the exponent, the exponent on the variable, so it's x to the first power. That's a degree 1. So we can identify whether a function is linear by the exponents on our variables. So here are some rules. 1, we don't want any variables in the denominator, because that would be a negative exponent. So no exponents other than 1. So x squared, x to the third, x to the 2/3. That's all nonlinear. Exponents like 1/2, which would be a square root, we don't want to see any of that as well. So anything that's kind of weird with your variable is going to give you a nonlinear function. So let's take a look at some examples and see if we can determine which ones are linear. And if not, we'll state why. So the first one here, f of x equals -3/4 x plus 8. This is a linear function. We have x to the first power. This is actually a function in slope-intercept form, or y equals mx plus b. Our second one, f of x equals 2 over x. This is not a linear function because of this x in the denominator of that fraction. Example C, we have a parabola. This is a curve on this graph. So this is obviously not a linear function because we don't have a straight line. So this is not a line. Example D, we have x plus 13 all over 2. Now we do have a fraction here, but because x is not in the denominator, this is okay. We could split that fraction up into 1/2 x plus 13 over 2, and that'd be fine. Example E, we have 2x squared. There's the red flag there. This is not a function because of that x squared. And then F, y equals square root of x over 5. Same deal, we have a square root of x. That's actually an exponent of an exponent of 1/2, which gives you that square root. Now that we can identify linear functions, let's talk about standard form. So standard form of a linear equation must be in the form ax plus by equals c. We have some rules here. First of all, a must be positive. Right, so a's got to be, the first term must be positive. A, b, and c are all integers, positive or negative whole numbers. So we want no fractions in our standard form. And also we want this to be in simplest form. So we'll divide out any GCF if possible. So we're going to write each function here in standard form, find the x and y intercepts, and then graph them. Now remember, at the x-intercept, y equals 0. And at the y-intercept, x equals 0. So we'll use those two facts to find our intercepts when we get there. All right, so first of all, we have 2y equals 4x plus 8. Now remember, we want this to be in the form ax, that's too big, ax plus by equals c. So what we have to do first here is move this negative, we'll move a negative 4x over. So subtract the 4x. We have negative 4x plus 2y equals 8. Now two things have to happen here. One, we want a positive leading coefficient. And also, all of these are even. I can divide them all by a 2. So let's divide by -2 to take care of both of those things. We'll get a positive 2 on our first term, and then we won't have any common factors to divide out. So there's our standard form, 2x minus y equals -4. All right, now let's find our x and y intercepts. So at the x-intercept, y equals 0. So I'm just going to put 0 in for y. I've got 2x minus 0 equals negative 4. And just 2x equals 4, negative 4. The great thing about standard form is that you can just zero out one term and then the other to find the intercepts. So I know that the x-intercept here is negative 2. Similarly, for y, the y-intercept, guess I can write intercept here. I'll put 0 in for x. So 0 minus y equals negative 4. So negative y equals negative 4, which means y equals 4. Now that I have my x and y intercepts, I can graph those on a coordinate plane. X is negative 2, y is 4, and now I can connect those with a line. So there's my linear function on the graph. See if I can get that line a little more accurately between. There we go. And there's my standard form, 2x minus y equals negative 4. Example B. The only thing out of place here is this 9. Let's move it over. 3x minus 6y equals 9. Now I can divide all this out by 3. We have a common factor here. So x minus 2y equals 3. There's my standard form. A is positive. A, B, and C are all integers. Looks good. Now let's find our intercepts. At the x-intercept, y is 0. So I know that x just equals 3. Just take that minus 2y out. We're left with that. At the y-intercept, x is 0. So negative 2y equals 3. Well, we'll divide by negative 2. And y equals negative 3 over 2, or we'll call it 1 and 1/2. That's a little easier to graph. So on my graph, I've got an x-intercept at 3 and a y-intercept at negative 1 and 1/2 right there. There's my line. Okay, our last example has a fraction, and you can kind of decide when to take care of these different things. I like to put them all in the right spot first. So we'll subtract 8y, negative 7/10 x minus 8y equals negative 5. Now to get rid of that 10 in the denominator, I'm going to have to multiply by 10. Because a here is negative, I'll also make it a negative 10. So we're going to get 7x plus 80y equals 50. No common factors here. That is my equation in standard form. Don't let the 80 throw you off. That is correct. Let's find our intercepts. So if y is 0, that means I've got 7x equals 50. Divide by 7. And x equals 50 over 7, or 7 and 1/7. It's a little easier to graph that as a mixed number. For my y-intercept, put 0 in for x. So 80y equals 50. Divide by 80. And y equals 50 over 80, or 5/8. Just take off those zeros. So let's graph these. 7 and 1/7 for x. Now this graph only goes to 6. Well, we can put a 7 right here, and maybe an 8 for a little context. So 7 and 1/7 is 5, 6, 7, and a little bit right there. 5/8 is a little more than 1/2, which is right here. Estimate, get close enough, and then do your best to draw that line through your 2 points. So standard form is ax plus by equals c. Rearrange your equation to make that happen. Make sure you have all integers with a positive a, and then you can zero out y to find the x-intercept and zero out x to find the y-intercept.